everyone, Brendon here. Today I have Jeff Schaefer with us. So Jeff is Graco Sanitary Product Manager. So one of the questions that we hear the most often when we're talking about getting new pumps for people is what pump do they need for their material? So in the next couple episodes, me and Jeff are going to be talking about factors that we consider in helping you select the best pump for your process. Last time that we talked about sanitary certifications, which also goes into this.
Yep.
But so today we'll talk about material viscosity and how that affects food, beverage, and hygienic fluid transfer. Hi, Jeff.
Hi, Brendon.
So what does viscosity mean?
Most people think of viscosity as like thickness, right? So water is very low viscosity, thin fluid. And then you have materials like stuff we do like peanut butter, right? Or tomato paste, which is very thick fluid. Scientifically, I think it's like the friction internally in the fluid, right? So the more friction there is, the thicker a product feels, which means it's generally harder to pump, right? The thicker it is, the harder it is to get from point A to point B.
Okay. So how do we determine the viscosity of a material?
So there are specific instruments that are used, like a viscometer, to test viscosity. We use a Brookfield viscometer here at Graco. So in our lab, Jeremy Williams, who you've met before, we'll get material in. And viscosity is kind of one of the first things that we use as an indicator on what pump you should use, right? So if we're kind of questioning what type of pump makes sense with a product, we'll bring in a sample of it, we'll put it on the viscometer, and then we'll get a range. Generally, we're reporting that back in centipoise is what we get. So, anywhere from water being something like 1 centipoise up to, tomato paste, 150,000 centipoise. We've done silicones upwards of 2.5 million centipoise, right? Very, very thick fluids.
Mm-hmm. Okay. So obviously, the material properties is really what drives viscosity, but I'm assuming there's some other things outside of those specific properties that we need to look at. So what other things affect the viscosity of a material? Yeah,
well, one of the main things is temperature, right? So if you think about cooking at home, if you heat stuff up, it usually gets thinner, right? Kind of like you're melting it. So a lot of food manufacturers, if they don't have the right equipment to pump stuff when it's cold, they'll heat that up, whether it's through a blanket or a hot room, and they'll make it lower viscosity so they can get it into a pump. Pressure can affect it as well. There's things called like thixotropic fluids. So one of the best examples is ketchup, right? If you take a glass ketchup bottle and you tip it over, it doesn't go anywhere, right? And you tap it on the bottom of it a little bit, and then all of a sudden the ketchup starts to flow. And then once it starts to come out, it comes out really fast, right? And that's because once you start ketchup flowing or tomato paste flowing, it's thixotropic, it wants to flow very easily. So when it's just resting, it might be like 150,000 centipoise, but once you start pushing on it, it's going to be like 40,000 centipoise.
Okay. So what are the general ranges of the viscosity that we look at, when we're starting to look at getting pumps spec'd for a certain material?
Yeah. So, we can talk numbers, which is all well and good, but
doesn't really mean anything to anybody.
Doesn't really mean anything, right? Because nobody's going to measure it in the field. Right. So we usually generalize and say, if you can pour it, right, out of a jar and it pours really easily, like a juice or a dressing or something like that, you can probably use a diaphragm pump or other types of pumps in the industry, right? Like a PD pump, rotary lobe, or progressive cavity. It'll flow into that pump pretty easily. If you need to squeeze it, a good example of this is like toothpaste, right? Like you squeeze it out, but if you squeeze it out, it'll kind of self-level. You probably need a piston pump to kind of get that pump check into the fluid and make it easier to pump. If you have to scoop that material, think of peanut butter or tomato paste where you take a spoon, you scoop in the middle, and that hole stays there. It doesn't fill in. Then you probably need what we would call an unloading unit or a ram unit. And the biggest driver for those different pumps is not whether or not the pump can pump it. It's whether or not you can get the material into the pump effectively, right? And a lot of people don't think about that, right? And that's where viscosity is really, really tough to deal with. The thicker it is, it's harder to get stuff into a pump to actually pump it.
Okay. What about like other pumping technologies? So if we start looking at like a centrifugal or a rotary lobe, where in like gear pumps, where do those fit into that range? Generally speaking,
on the lower end, right? Okay. And that's because they don't pull suction and they don't have anything aiding them getting the material in, right? You're not gonna take a tub of peanut butter and have a rotary lobe pump pull it out, right? You're not gonna take any pump and have it pull it out, right? You need a ram unit for that. So most of the time, dressings and sauces and low viscosity ingredients, all those pumps work just fine. And they're widely used in process environments, right? Once you get to thicker products that are going into mixed kettles and ingredients, then you need to start looking at some alternative technologies. Diaphragm pumps do a little bit better because they self-prime and pull suction, as you're aware. Piston pumps are even better. And then we get up to the RAM units for ingredient transfer.
Got it. Okay. So outside of those factors that we talked about, material properties, temperature, pressure, what other things can make a material harder or easier to pump?
Yeah. So you think of like stickiness, right? Surface tensions and that kind of stuff. We recently pumped a face cream and it was probably a couple 100,000 centipoise, but like most lotions or creams, it was very oily and it was slippery, right? We also pump fruit pastes that are a couple 100,000 centipoise. And those are very sticky, right? And that stickiness or surface tension of the material is a big factor. The amount of sugar in a material can make it harder to pump. So there is other outside factors. Your viscosity may be the same, but there may be other things that make it easier or harder to actually move that liquid. But generally speaking, we start with viscosity as the best guideline as far as what pumping technology or what system we need to kind of get things going. Okay.
So I know with our unloading technology, we do offer a piston or a diaphragm pump to help unload. So would viscosity be the reason that you'd switch between a diaphragm and a piston for the unloaders, or is it a different reason?
No, viscosity, right? Absolutely. Okay. So the thicker it is, you have the RAM unit kind of helping you get it in the pump, right? Not to go into too much detail, but some of our piston pumps have mechanical priming pistons that help as well. But once you get it in, then it's about moving it downstream as well. Diaphragm pumps are a 1-to-1 ratio, right? So if you put 100 PSI air in, you get 100 PSI fluid out. Piston pumps are not like that. If you put 100 in on our highest ratio pump, you get 1,200 PSI of fluid. Well, when you're pumping peanut butters or silicones and that kind of stuff, you need that outbound pressure to be able to effectively move it. If you don't and you just use a diaphragm pump, you probably are pumping it to one or two other pumps downstream to kind of move things along, which is just more equipment to maintain and more stuff to clean, right?
Got it. Okay. I think those were the questions that I had. Do you have any other comments you want to make on viscosity and how it relates to selecting a pump?
No, I think we covered most of it. The one thing I would recommend is, we hear the question a lot, like what pump should I use? And we have the capabilities at Graco, right? So if anybody is in question, talk to your account manager or talk to Jeremy in our training lab. We can test it. We can get it on the viscometer, and we'll get you that information, right? So don't just kind of go blindly into a decision. We can definitely help with that.
Awesome. We'll put contact information down in the description for those, and our process tech will also get you access to getting a demo material here, so you can see if our pumps are going to be able to pump your material. So this wraps up what we had to talk about. So thanks for spending time with us today talking about material viscosity. So make sure you visit us at Graco.com. Check out the description for those links on how to get a hold of our process tech and our process trainers. And then follow us on LinkedIn. I hope you guys have a good one. We'll talk to you later. Bye.